Hello guys, welcome back to John's Workshop, and in this video we're going to go back and do another one in the Workshop Tips series. So this is Workshop Tips number 9, and we're going to dig in a little bit deeper into the use of carbide, and that could be solid carbide end mills or sintered carbide inserts for turning tools, milling, face mills, that kind of thing. So why am I doing this? Well, I've been prompted by seeing quite a few different things on different YouTube channels, and largely, you know, this isn't an attack on anybody in any way, shape or form. If you don't know this stuff, you don't know it. It's as simple as that. Now, most of this comes from my own personal experience from when I didn't know it and I made the same errors. I'm not going to call them mistakes, I'm going to call them errors, and it's just, there's a few things that you can do with carbide to help prolong the life of your carbide inserts and your carbide end mills. And I see quite a lot of things that I think people are unaware of, the fact that they're probably risking reducing the life of their carbide, either an end mill or an insert. So there's, as I said, there's many examples of this that I've seen, and there's many examples from my own personal background that I've witnessed myself, and I've made the mistakes. I've said the word mistakes, I said I wasn't going to. I've made the errors myself just through not knowing, and it's only through repetition of those errors, and you start to build a picture up and you go, okay, I'll not do that again, that you start to build that knowledge up. So I want to pass as much of that on as I can to other people, because as it says on the board, despite the advent of Chinese carbide, which has drastically reduced the cost, especially to the home shop world, which will be the only people who buy it largely, you know, that stuff's no good in industry, it's still expensive, especially when you get onto the end mill side of it. You know, inserts are pretty cheap, but you know, if you can make an insert last twice as long, guess what, you spend half as much money. So it doesn't matter how expensive or inexpensive they are, being frugal with them and getting the best out of them is still a good idea. So this is all about making that carbide last longer. I'm going to do this through a series of practical demos rather than just sitting here and babbling. I'm going to try and set some demos up to show you the types of things that I've seen and the types of things that you shouldn't do. And as you'll see in one of the demos, I'm guilty as charged, because I'm doing exactly what you shouldn't do with some of the carbide, mainly around storage, but I'll show you some of that. And as I said, save yourself some cash. What's not to like? So I will get the first one of the demos set up probably around the lathe. I think we'll start with the turning inserts for a start and go through a couple of examples on the lathe, and then we'll move to the mill. So I'll bring you back in a moment at the lathe. Okay, so here's the first example. So we've just parted something off the end of this bit of bar, and we're now going to move on and turn something else, or our next component or whatever it is, out of this bit of bar. And we've got our, you know, if we're using a carbide insert parting tool, 9 times out of 10 you're going to get left with a pit like this, or you would even with high speed steel, depending on how it's ground. And what I see people doing is how I've got this set up here, and this is why, you know, not just people, me as well, I've done this and this is how I learned. So I'm not, you know, I say again, I'm not pointing the finger at anybody. This is about everybody sort of learning. So I'll see people and myself in the past have touched on the face. I'm just going to take a facing cut straight off, and I'm going to face all the way in and just get rid of this pit. Now, what you need to understand about this is your surface speed. So that's the speed that the material is actually passing by your insert when you're down here is next to 0, because of the diameter and the relationship with pi. When you do a pi d to work your circumference out and times that by the speed, your RPM that you're running at, your surface speed is pretty much 0 here. So think about what you're doing. You're going to plough your carbide tip into something that's big with almost 0 surface speed, and basically just try and break it off, which is largely what happens. And there is always a risk that in doing that, if any of that kind of flicks back round and comes up and sort of pushes upwards on the underside of the insert, which can happen, it can fracture the corner of the insert, the very edge, the cutting edge of the insert, and you might not even see it. But what you will find out is 2 cuts later down the line, you'll say, oh, my insert's got a chip in it, or it's buggered, but you won't associate it with the fact that it happened when you were actually doing this, and you'll think it's happened when you were turning the next cuts on the OD. So I'm not going to demonstrate doing that because I don't want to waste an insert edge, but what I am going to do is demonstrate the way I've learned and seen, you know, good practice to not risk that damage to your insert. Okay, so this is the best way to get rid of the pip. So nice and simple, you actually turn it off as opposed to trying to face it off, and that just means you're putting no unnecessary load on your insert edge and you're not risking that damage, that fracturing of the carbide. So the next one we're going to talk about is actually the operation of facing a bit of bar off. So I'll just reposition the camera and we'll come back in to do that one. Okay, so let's imagine we're now going to face this bar end off. We've got rid of our pip and we're now just going to face this bar end off, ready for creating a face for our next component, whatever that's going to be. And anybody who's wound handles on a lathe will understand what I'm about to say next. As you progressively move closer towards the centre, the resistance that you feel in the cross slide handle will get less and less, and there is a temptation to wind faster and faster at that point because you can feel the resistance easing up, which is totally counterintuitive. Well, it's not, it's intuitive, but it's totally counter to what you want to be doing. The reason the resistance gets less and less as you get towards the centre is because less material is passing past your cutting edge, which means you're physically, the tool isn't working as hard because you're cutting less material in every second, in every minute, and therefore the resistance gets less, so you're tempted to just wind harder. What you're actually doing, as the closer to the centre you get, your spindle, your surface speed, which is the rate that your material passes your cutting edge, is getting lower and lower and lower and lower to 0 when you hit the centre. And what you should be doing is winding, therefore, slower and slower and slower as you go towards the centre, not faster and faster. And again, very similar to what we just discussed on the parting off of the pip, well, you know, get facing off of the pip that you get left from parting, you again stand the risk of pushing the insert through the material rather than letting it cut its way through the material, and again you risk fracturing the insert edge here because of that particular action. So just be aware when you're facing off, as you get towards centre and you feel that resistance drop as you go closer to centre, don't be tempted to wind harder and harder. If anything, back off with the speed that you're actually moving, because your spindle speed's static, therefore your surface speed drops with every millimetre, or, you know, whatever it is of an inch that you get closer and closer to that centre point. I hope that made sense. I've tried to explain it as simplistically as I can, so just feel that, how that feels, and when you feel the pressure start to drop, actually decrease your traverse speed with your hand on your cross slide, not increase it, and that will protect your insert from hopefully any damage as a result of pushing it through almost static material. Okay, we're on to the next example now, which is turning an OD or boring an ID, doesn't matter, they're both the same with this principle that we're going to demonstrate. So I'm just going to put a cut on. Now if you see what I did there, I stopped my traverse and then I stopped my spindle without retracting my cross slide or winding my carriage back off the material while the spindle was still spinning. So basically what's happened is the material has come to a stop in contact with the carbide insert. Now on many belt driven lathes like this is, when you stop your spindle like that, then what can happen when it reaches an absolute stop is the spindle actually just, you know, very slightly goes back into reverse. It doesn't obviously start in reverse, but just with the inertia of it coming to a stop, when it gets to a very fine stop, it can sometimes often rock back just a little bit, and that could be caused by the shape that you've got in your belts or a whole manner of things. If your insert is still touching both the diameter and the face that you've just produced, and that, you know, your spindle does do that tiny bit of reversing, again there is a chance that you're going to lift the very surface of the carbide and break down its condition. These things are great in compression. The minute you put them into tension and try and lift or run backwards in any way, shape or form, they will just break very easily. They have got no strength at all in tension. They only work in compression. So whilst everything's going in a normal direction past them, very strong, if something suddenly wants to run backwards past them, they just shatter incredibly easily. Now what you may not even see it at that point, a bit like when you were facing the pip off. It may have done the damage, you can't see it visibly. 2 cuts later down the line, I've got a chip in my insert. I don't know where that came from. I need to change my insert over. Seen it so many times. And it's, yeah, retract the tool either in the cross slide or wind it back off the part with the carriage while the spindle's still turning. Do not stop the tool in position as I've just done there. What I've also seen a lot of and done myself many times in the past is, once you've got to that position and you say, oh, I want to measure that now, I see this happening, and you won't be able to see it, but there is a line in my OD here that the tool has just scribed on its way out. It's the same deal. I'm trying to push my carbide insert through static material, dragging it backwards. It's not a good thing to do. It could fracture the insert, weaken it. Again, you might not see it when you do it, but 2 cuts later down the line or whatever, with the cut pressure back on the insert, it will fail, or it could fail if you've damaged it. So again, removing carbide past a static part that's not moving is never a good idea. So always retract with the spindle running, or wind your cross slide back off, or if you're in the bore, back towards centre and get out of the way before you stop your spindle. Do not do this winding inserts across static material. It's not a good idea, and you will definitely, over time, it won't happen every time, but a number of times you do that, you'll damage your insert without a shadow of a doubt. I've done it many times, witnessed it myself, and then that's how I've got to the point of realising that that's not a good way to get the best life out of your tools. So we'll move on to another example now. Again, it'll be on the lathe. Okay, so here's the next example. So this is 65mm diameter, unknownium, some kind of carbon steel. Let's assume that my part I need to make, I've got to reduce this down to, I don't know, say 20mm diameter or an inch, there or thereabouts. And I've got to take a good load of material off, and I've got to do that right the way back up to the chuck jaws and leave a flange on the back. So a lot of heavy turning to do. So this thing's going to get hot, my tool's going to get hot whilst I'm doing that. And carbide, unlike high speed steel, I could run that, I think this is a carbon steel of some sort, I could run all of that dry. It would start, the lathe would start smelling, and anybody who's done this will know what that's like. And then you get to a point that you need to measure something and you think, alright, my last 2 cuts, I'm going to start squirting this stuff all over it, okay, just to keep it all cool. And there's lots of steam and lots of stuff going on, and as everything starts to cool down, what will have happened there is your insert will also have got as hot as your part has, or if not hotter. And if you suddenly quench that once it's got hot with a lot of cooling very fast. It's a bit like taking something glass out of the dishwasher and instantly putting it into cold water, or taking a plate out of the oven and standing it on a cold surface. It's going to shatter. And the same thing's true with carbide. So carbide does not like to be hot, cold, hot, cold, hot, cold. So rapid changes of temperature means it's going to expand and contract incredibly quickly. If you've got it under pressure while it's doing that, i.e. in a cut, there is every possibility that it's just going to start to break down very quickly, or if not, catastrophically fail. Now, anybody who's watched a lot of my videos would have seen me using this dropper bottle, especially on the mill, and I'm periodically adding coolant, which kind of goes against everything I've just said. Slightly different in the fact that I do that right from the start, which means that my tool has never got that red hot to start with before I've quenched it, and also all the stuff I do in here is fairly lightweight. I'm not hogging great lots of material off, so I'm not getting that lot of heat built up into my insert, my tool body, my tool posts, my cartridge, the part, the chuck, because the heat transfers through all of it. I'm not building that mass amount of heat up to then suddenly instantly try cooling it. But good practice is not to shock an insert with quick changes of temperature, and that's the same on a mill, on a lathe, doesn't matter where you're doing it. So just think about your coolant application and try and keep it as consistent as possible, and all the way from start to finish consistent, so that you're not building up an excess of heat and then suddenly trying to cool it, especially when you're in cut. So just another one to think about. Okay, next one, and anybody who knows what I'm about to say will see that I'm living in a glass house and throwing stones here to a large extent. So storage. So if your inserts come in one of these boxes, leave them in it. This separates them from each other, stops them getting damaged in the storage location, stops them bumping into each other or anything else bumping into them. For end mills, again, if your end mill has come in one of these, leave it in it. If your end mill hasn't come in one of those, don't do what I've done here, which is put them all in a box. Now, I've kind of carefully put these in. I know that doesn't look like I have, but what I mean by that is I've not thrown them in from this distance, which again I've seen some of that happening on some of the YouTube channels. If you do that with carbide, or even with high-speed steel, you're going to damage your cutting edges, right? So high-speed steel, you'll get away with it more. It's a bit more forgiving. You might put a bit of a chip or a ding or blunt it. Carbide, you're just going to chip it. And once you've chipped, in a home shop, if you're looking, you've got a tool and cutter grinder, you can probably clean up and regrind the ends. Regrinding the whole of the outside of the flutes is much more involved. Not many people have that ability. If you knacker the cutting edges down the side of this, then you're really shortening the life of this. And again, these are, even with the cheap import carbide end mills, they are still not cheap. So it pays you not to do that. And as I've shown in my last Blether video, I've bought some proper end mill storage to get me away from this situation, because I'm not comfortable with it and I don't like it. So I've got some proper storage that's going to get these out of this limb bin and in some proper storage, more akin to how these are stored, all separated from each other. So just beware how you store your end mills. If you've got them in a drawer and you shut the drawer hard and these things start bashing and clattering into each other, you're going to do damage to them. It's as simple as that. So just some thoughts around storage. Okay, last one for the lathe. So if you've got a DRO on your lathe, don't do this. And I have seen a lot of this. So I've faced my end up there, so I know where that is. It's where I need it to be, and I've turned my diameter, and I know what that diameter is. But I didn't do anything with my DRO when I did it. So I'm going to come back in afterwards, and I'm going to bash my carbide insert into my static piece of material and hit Z0 on my DRO, and then I'm going to come off. Or what I have seen actually is I've done that, I've bashed it into the static material. I'm now going to, and I'm not doing this because I don't want to waste an insert because this will break it, I'm now going to back my cross slide off in static material and wind it off and leave a line, clearly visible line where my insert's dug into that face. Two things there: one, you've damaged your part, and two, you've probably fractured your insert. And then once I've fractured my insert and damaged my part, I'm going to come out to the front and I'm going to do exactly the same thing to work out where my diameter is. So I'm going to whack my carbide insert into the diameter that I've turned and then dial in a value on my DRO because I've measured this and I know what it is. Both really bad practice, not only from a part perspective, you're going to just leave marks all over your part when you start doing stuff like that, but moreover, and what this video is about, is you're not doing your insert any favours doing that kind of stuff. So always do this dynamically, and what I mean by that is if you want to touch back onto something you've already turned, have the spindle running when you do it and just gently bring your tool in until you just hear it or just see it touch. Don't be winding this thing in while this isn't moving, because you're not going to do it any favours. Okay, we're going to move on to a milling example now. So we've got a solid carbide 4 flute end mill in the collet chuck. I've got a piece of work in the vise and I want to know where this face is, and I don't want to go to the hassle of breaking all of this collet chuck down and putting my edge finder in to find it. So I'm just going to touch on using the end mill, and I've done this quite a few times in my early career until I realised what was going on. So I've been doing this, which is typically what you used to do with a high-speed steel tool, backwards and forwards like this until you just come in, and I'm not going to touch the part because I don't want to ruin this end mill, but largely winding in until you just feel that you've got a touch on the side of the part. No different to what we've talked about on the lathe. What we're doing there is we're turning the carbide both forward, which is the right direction past the material, and backwards, and the minute you do that, whichever cutting edge touches the part, you're just going to crack and splinter that cutting edge by turning it backwards past the material. So same principle applies with an end mill as it does with an insert. These things do not like any kind of backward or tension type forces applied to them. Everything needs to be compressive, it all needs to be running forwards, and exactly the same as a lathe. If you want to do this and touch on with the end mill straight onto the side of the part, do it dynamically, do it with the spindle running, and just move in till you just gently hear the end mill touch the part. And there's another good reason for doing that as well, which has got nothing to do with saving carbide, but if you've got any kind of run out at all on your end mill, in your ER collet chuck or in your spindle nose, then you might have picked the wrong cutting edge there. You might have picked one that's too far away from the part, whereas if you'd picked the one 180 degrees opposed to it, you would have touched on sooner because you've got a bit of run out in the end mill. Whereas if you're spinning and doing it dynamically, you will touch on the highest point, whichever flute that is that passes by the workpiece first, which kind of doesn't take your run out that you've got into account, but it means that you are touching on the highest point, if that makes sense. So this is true for both touching on the edge of the end mill and also touching on the underside, on the end of the end mill onto the top of a piece of stock. No different, same deal applies. Again, I've done it and I've seen other people doing it, this kind of backwards and forwards thing to try and see when you've just touched on. Don't do that. Similarly, something else that I've seen done and I've done myself years ago is, rather than touching directly onto the part with the tool, is putting a feeler gauge in between the two and largely doing the same thing until you get a feel with a feeler gauge. It makes no difference, it's metal to metal contact, and you will still break down your cutting edge if you run that backwards past the feeler gauge. So that's that example out of the way. So while we've got the camera in this position, and the tool holder where it is. Here's another one. This one's fairly self-explanatory. Going to take my tool out of there, and I'm just going to undo. I'm not going to do it because I don't want to cause the accident. So I've got my finger on the end mill here. But if you didn't have, and you undo your collet chuck, all of a sudden, if you've got a slightly loose tool or a loose collet, that's just going to fall straight out. It's going to do two things. One, it's going to chip your end mill, probably render it useless, and secondly, it's going to put a nice big divot in your bed of your machine if it hits the table. So again, two things you can do there. One is be very careful and use your finger like I did just to exert a bit of sideways pressure when you're undoing. The second one you could do is to use something like you would use on a lathe and do all of your tool changes over a piece of wood, which is good practice anyway, especially if you're putting spanners down onto your table bed. So I think that's probably it for the milling examples. Other examples transfer across from the lathe, such as hot and cold chilling with coolant, exactly the same as for an insert on the lathe. Running, touching onto a piece of work and then lifting your spindle up without it running, same deal. It all carries across it. You need exactly apply the same rules around using carbide on a mill to what you would do with an insert on a lathe. It's no different. Well, there we go, guys. I hope you found that useful. If we've managed to save one edge of one insert or one end mill, where somebody has found something out there that they didn't previously know or understand, then this video in my mind has been well worthwhile making. So a lot of you will probably already know this stuff, but there may be some out there that don't. So I thought that's why, well, there's obviously some out there that don't, because I see evidence, put my teeth back in, I see evidence of that on YouTube quite regularly and quite often. So it's always worth treating carbide as though it's some fine porcelain china in your house, and treat it with the same levels of respect in terms of handling and in terms of how you use it on a machine. And you will, just by the very nature of doing that, you will make your carbide last longer and you will save yourself some money. So hopefully you found that useful. I'd like to thank all of you for viewing and subscribing, and the new subscribers that have come along, and we'll catch you all very soon on another video when we'll be making something else.